Hello, my dear students. Welcome back to my class. In the series of learning programming in C, in the previous video, we discussed about static storage class. Well, in today's video, we will discuss about register storage class in C. So, what is this register storage class? How to use this register storage class? Let us understand with a small programming example. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Register storage class in C. So what is this register storage class? The name itself tells you it is a storage class which is of register type. In the sense, we are telling the compiler that the variable should be stored in CPU register. So what is the CPU register? Let us understand that first. So inside the CPU, we will have small storage areas called as registers. There are temporary storage areas, and when the data is stored in these temporary storage area, that is inside the registers, it provides faster access to the CPU. So every time it's quite difficult to fetch the data from the hard disk or from the RAM. So if I have the data in the CPU registers itself, so registers will be inside the CPU itself. So if the data is placed inside the registers itself, it will be easy for the CPU to access the data from the registers very quickly and process it very quickly. So here, when I use this register storage class, it is a straight instruction to the compiler saying that the data has to be stored inside the CPU registers, not inside the RAM. So what actually this register and how to use this, let's see now. So register variables will be stored in CPU registers. So when we have a variable of register type, the data of those variables will be stored in CPU registers. CPU registers provide faster access to the data because it will be inside the CPU itself, and obviously the data which is in the registers can be easily accessed by the CPU and it can quickly process it. So these registers are small storage areas. We cannot simply dump huge data there. And one more thing to say here, frequently used data will be stored in registers. All the data we cannot store in register. The frequently used data can be stored inside the registers so that the CPU can fetch the data immediately. It cannot go and search the data in RAM or hard disk. It consumes more time. So if it is available in registers itself, then I can easily access, means the CPU can easily access. But to tell you one more thing about these registers, these register variables are not used with modern compilers. Modern compilers are usually better at optimizing the variable storage by themselves. So we need not say, the user need not say that it should be of register type or it should be of the auto type, all those things. The compiler, the modern compiler itself decides where to store the data. If it is frequently used data, if the CPU has to access the data again and again, then the compiler automatically decides that the variable data has to be stored in registers. So the user need not break their head to decide where to store the data inside the RAM or inside the registers. The compiler itself optimizes the variable storage by themselves. Hence, the keyword register is often ignored by modern compilers because modern compilers has the capability to decide where to store the data. If it is frequently used data, then it will decide that the data has to be stored in CPU registers. If it is not frequently used data, then it can be stored in RAM itself. So hence, modern compilers will not use these register. But previously, we use these registers, register variables. So how to use this? So as usual, we have the keyword register followed with the data type and variable name. We can initialize the value or we can accept the value from the runtime also. So what are all the aspects that we need to talk about these register variable? That is the default value. So what is the default value, it is garbage value, junk value. Location, CPU registers. Scope, that is local to the block or function where it has been declared. It is local to a particular block. And lifetime, it is only within the block or function where it has been declared. So we use these register variables and we instruct the compiler to store the data of this variable in the CPU registers if it is frequently used data. So let us understand this with a small example program. So here is a very simple example program to understand this register storage class. The same program if you do with auto also you get the same output. Only thing, the compiler is going to decide the storage location of these variables that what we have declared. We are just finding the sum of the numbers where the control variable I is used repeatedly, frequently. So what I'll do, let me draw the memory location. So inside the CPU, as we all know, CPU is made up of many subunits. You have ALU, you have control unit, and you have registers. Right. So two direction arrow. So the CPU is made up of many units, and again there are still so many subunits and we have specified only few major units. We have instruction register, program counter. Like this, it is made up of many small components where ALU, CU registers are the major components which are available in the CPU. So for this program, so as we all know, the program will have different frames to store the data. All the code and instructions will be stored in one frame. Then you have all the local variables, static variables, and the global variables in one frame. Then you have the stack frame, and then you have the heap frame. Now, so we have some local variables here where these local variables are stored in registers because the variable I and sum that what we have, it is of register type. It is of register type. Means inside the registers we will have the memory block for I and then sum. Inside the registers, we have the memory location for I and sum. Why we are storing this inside the registers? Because the value of I and sum is frequently used in the calculation part. So every time for processing, the CPU need not take the data from the main memory, that is from the RAM. It can straight away take from the registers so that it can process the ALU and CU can process the data. So we have the for loop as usual, I equal to 1, I less than or equal to 5. So I just say I equal to 1, 1 less than or equal to 5. Condition is to get inside, do this computation. Sum is initialized to 0. 0 plus, this is what the I value, 1. So it is 1. So again loop back, I gets increased, I becomes 2, 2 less than or equal to 5. Yes. So it is sum equal to, sum is 1. See, the sum value is getting changed, the I value is getting changed, I becomes 2, sum becomes 1, then 1 plus 2. It is, sum value is 3. See again sum is changing. So frequently we are using the I value and sum value. So it goes on like that and we get the answer 1 plus 2. So it is 3, 3 plus 3. It is 6. It goes on like this and the loop ends and will come out, will print the sum value. So here what you need to understand is the value of I and the value of sum is being used frequently. So we are storing that inside the CPU register so that the CPU can process it very quickly. But the modern compiler will do that automatically. We need not mention that it is register variable or auto variable. It will optimize the location by itself. So if you just run this program and see the output, you get the sum of the numbers. If you do that with auto also, you get that. But only difference is the time that what it is going to take. If you are running the program with modern compilers, it will automatically decide the frequently used data location that it has to be stored in registers, and it will do the computation. But nowadays, all the compilers have these capability, and it will optimize the location by itself. So this is what with the register storage class. So we have completed with all the storage classes. We have dealt with auto, extern, static and register with programming example. Just execute this, you get the sum of the numbers, that's it. If you do this with auto also, you get it. Only thing, the location of the data, that is I and sum, varies. If it is auto, it is RAM, the location. If it is register, it is inside the CPU register, so that it can access the data very quickly. So that's all for today's video. See you in the next video. Till then, take care. Bye bye.